All right, guys, it's been a couple weeks since I posted. I think last video I posted of the Mustang was the Grudge race versus that Evo. We've been to the track a couple times. We haven't had much success. We had the car turned up pretty hard. Here was an attempt from a couple weeks ago. Check this out. Okay, so as you can tell, the thing spun. This one was a little bit different. If you watch the video and slow it down, it spun the tire as soon as it set the front end down. Now, the previous one, when I raced the Evo, it spun the tire as soon as it hit the top of the shock, which obviously removes weight from the back of the car. The same thing is kind of similar when it sets the front end down. I've got a bit of compression in this thing. So when it sets it down, that weight's going back onto the front tire, off the rear tire, and it knocks the tire. Yeah, I probably could have made some setup changes or pulled some. I definitely could have pulled power out of it, make it down the track, but that's not the point. The biggest thing on both of those passes, the Grudge race versus the Evo and the previous video, and then this one when it spun the tire after it set the nose down, is that this is test and tune prep days, and I know that I'm asking a lot out of the prep that's on the track. There was literally, I mean, almost nothing. I'd have been way better on a 28-10.5 tire, but I know that the radial tire is going to be quicker, and being that we're basically just out here to try to better our stock engine record, it didn't make any sense to put the bias ply on it. It didn't make any sense to pull power out of it. Obviously, that's the wrong direction. I knew from where we had ran it before that what we needed to see in a 60 foot, and I know what kind of power it takes to get there. So if the combination wasn't there, it just wasn't worth it. So we ended up skipping a week. We went there this last Saturday, and had the thing turned up pretty hard. We left on 20 pounds, ramped to 26 over 0.8 of a second. Check the video out from this. Alright, so that thing spun there too after the 60 foot. Now if you watch the video again, you'll see that the biggest thing here is it was 48 degrees out, something like that. It was pretty cold. They had just prepped the track. Samuel, the guy that preps at Martin, was back, and he put some good prep down for a few radial cars that were there, and I was first down the track on the fresh prep. I don't know if the prep didn't have enough time to flash off because of how cold it was, if it just wasn't dry enough. If you watch the video, I rolled through after the burnout. That's what the tracks are to the 60 foot before I leave, and as soon as I go beyond where my tracks were, it immediately lights the tire up. So that was kind of ended. Well, we planned on making another attempt after that. It was still cloudy at that point. Again, 11:30 in the morning, 11:45, and they were running till 6. The sun started poking out, and it was looking good. We were excited. All the data looked good from the little bit of the pass we made. The 60 was a little slow for the power level we had in it, and I think that was just because of the trans temp. The trans was only 125 degrees. I think that it just the fluid thickness, because it's a 30-weight trans fluid, I just don't think the converter could couple fast enough because of how thick the fluid was. It had 208 pounds of converter pressure because the fluid was so thick. So I don't know. I'm not sure because obviously I wasn't able to back that up, but that was on more power than we had been 124 60 foot before. Watching the video, it looks like it spun right at the 60 foot, so that could be all of it. Hard to say. I don't have the G meter hooked up because I moved that input to the pre-intercooler pressure sensor. So I don't really have that data to overlay, and from the 859 pass or the 124 60 foot pass from before, I didn't have drive shaft speed data at that point, so I really don't have a data point comparison. Anyway, after that, the track started looking good, and the timing system of the track failed. Now, they have a backup setup. They put the backup setup in it, and they couldn't make that work either. So unfortunately, that ended our season going to the track this year, which is a little, yeah, it's a little sad, little, you know, whatever. It sucks to go out like that. The weather was perfect yesterday and we were ready to make another attempt, but it happens, you know, we move forward. So I'm getting this thing ready for winter. Yeah, we're happy with the year. I mean, obviously we broke the stock engine record beginning of the season. That's cool. I'll put a link in the description, or maybe I'll put a thing up here for you to click on to check that video out. Yeah, so I'm excited. I got a list of plans we're going to do over winter. We're planning on possibly mixing this up a little bit next year. I'm going to leave the setup alone for now. We're going to put a bigger charger on it. I'll go through the data log here in a second and show you a few things, but this has got a billet 80 on it, an FI Force Inductions billet 80 on it. We're going to put their new 94 on it is the plan. So because the 80's pretty close to being maxed out again, I'll show you that in a second in the data. And the intercooler, pre-intercooler pressure sensor is showing that we don't really have a flow problem there yet. Even up to 26, we had 26.5 pounds through it at that point at 7,000 before it spun. We're 85% injector duty on Bosch or Deka 220s on an E85 fuel. So that's like 1600-ish flywheel. So definitely making some steam. I'm gonna put a aluminum rotted sleeved Coyote short block together for this thing over the winter. I'm gonna put the whole engine together. I got another set of heads. We're gonna do some trick stuff with that. I'll follow along and I'll show you guys that stuff we're doing. And then yeah, that 94, we're gonna leave the stock engine in it and go after, try to better our stock engine record to the beginning of the season next year. I know the car's got more in it. I know we can do better than that 859. I'm hoping we can do an 830 with the car. With that setup in it, with that engine in it. So that's currently the plan. But yeah, gonna do a few other odds and ends. We're gonna put a wing on it and a chute on the car over the winter. It needs a chute. It's kind of a little sketchy at times. Thankfully, Martin US 131's got a long shutdown area, so that hasn't been a problem. But we're planning to possibly do some half-mile stuff with the car. My wife wants to drive it and go, goal is to go 200 and a half. The fastest female that we can find half-mile, I believe, has been 226. So that might be kind of my goal more than hers, but the single 94 will do it. We're gonna do that aluminum routed short block so we have plenty of power. That's the purpose of the new wing we're gonna put on the car, the parachute. I'm gonna do a couple other little aero tricks to it. I say tricks, I don't really know what I'm doing with aero stuff, but you know, common sense stuff. I'm gonna lower the car, probably put a little bit of a front splitter on it, maybe some sort of rail on the pinch welds down the side of the car, just to try to keep air from getting underneath the thing. Pretty basic, straightforward stuff. Gonna leave the hood exit on it, and yeah, that's kind of the plan moving forward. I'm gonna start, oh, I wanted to show you guys something. So I bought a new, after the car was spinning a bit, sorry, hold on. You see the wear difference in this tire? Look at the grooves here, right? See that groove's like, it's not just faded because it's a little dirty, it's almost gone. Look at these grooves here. See how deep these guys are? And see you got these intermediates here and the thicker ones on the outside. This one, you got the thick one there. This one here, look at the length difference in these two. That's how much that one's worn. This tire was definitely wearing oddly. So I bought a new set of radials for it. After that last attempt, after the grudge race where it spun really bad, I thought, man, maybe I need to put some tires on it. Put some tires on it, and that wear difference in those makes me think that I might want to put a spool in the car. So this still has a track lock currently. So I think that I'm going to put that on my list of stuff to put a spool in the car as well. Maybe that's creating some sort of an issue at the power level we're at. I mean, people have been faster than I have on it, right? So I don't think that that's a problem. I think a spool is just good insurance at this point. So probably going to do that. A handful of other things. I want to put a catch can in the trunk rather than up front. So if we do have some sort of catastrophic failure and it evacs itself, it all goes behind the car rather than under the tires. But yeah, I'm gonna make a list of stuff we're gonna change here and make videos of all that as I have been previously over last winter, so follow along with that stuff. But yeah, I'm gonna go through the data. All right, so here's the data log from that little 60-foot hit we made. Just to show you guys a few things we were looking at as far as the turbo set's concerned. I was worried that the intercooler was a common restriction. Obviously, if you followed along, you know that. But I put a pre-intercooler pressure sensor in it. And I don't turn the car up on the dyno for R&D purposes because, again, it's a stock stock Gen 1 engine here. So I'm pretty careful when we put power in it, usually when we're typically only going after bettering our stock engine record. But so I wanted to use this for some data purposes, and we were able to achieve that. Now you see, so these two lines here, the one that's a little jagged and then the one that's more solid, the more, not smooth signal there is the pre-intercooler pressure sensor, and the other one here is the post-intercooler pressure sensor. You can see there's a little bit of an offset difference here. Obviously, there's not really much way to have less pressure pre-intercooler or more pressure post-intercooler. But that's probably because of where I'm pulling a pressure source from, which I am going to move. That is on my list of stuff to do to try to clean these signals up. But anyway, you can see here, we're manifold pressure. Let's see if I can move that. Yeah, I can't. Manifold pressure, is 25-ish. We're 23.5 intercooler pressure. It moves around. They trend each other. You can see they trend really well. There is never a positive situation here. Here's when it free rev really hard. Well, when it knocked the tire off, went up to like 7,500. You can see they're dead nuts the same there. Or I'm sorry, went up to 8,000. But check out the exhaust manifold pressure. So we're 23 pounds of boost, 30 pounds of manifold pressure, 25 pounds of boost, 30 pounds of manifold pressure. So we've got some stuff to work on there. That's the biggest reason why I want to put the 94 on it. It's a 94-104, meaning that it's a 94 millimeter compressor wheel, 104 millimeter turbine wheel. Same T6 deal. I don't know what AR options he has for that. I'm gonna guess he's gonna suggest I put the 132 back on it because that's what's on it now. But I'll talk to Jose and he'll set me up there. So yeah, interesting data there. That stuff all is looking like, again, the drive pressure is starting to get up there a little bit. I think we've got a little headroom on the 80 yet. I think we could run this till we're almost double. So I'm guessing, we get to 28 pounds or so will be about out. But talking to other people with this same turbocharger on a Coyote, anything over 26, they said it started to get pretty numb to changes. It was about on its butt. So that's why we're going to move to that 94. So down here in the other setup we have intake air temp, this guy here. You can see it was down to 54 degrees there. 1.7 seconds into it when it spun. Was all the way up to 63. I did some quick math, considering when we go to half-mile stuff, figuring I'm going to be on the throttle, or Jesse, mind you, be on the throttle for somewhere around, I'm estimating greatly here, somewhere around 12 seconds. Now, granted, that whole time frame, we're not going to be at 25 pounds, just because it'll be so super traction limited. And 12 seconds is probably a stretch, but even at 12 seconds and an 80-degree start temp, figuring if we get the thing below ambient, that's cool, but we may not. We're going to end up with 150-degree intake temps at this boost level with this compressor wheel. So I'm okay with 150-degree temps, and I think that's kind of worst-case scenario. I don't think it'll actually get that hot. And if it does, I'll have to address it later. For now, I'm going to leave the intake manifold intercooler set up the way it is. My O2 sensor died. That's another thing on my list to do. I'm going to move the O2 sensor differently in the exhaust stream. This thing makes so much moisture, the water collects in it, and I can put the O2 sensor in a location that's more on a downward angle so the water wouldn't collect in it. So I'm going to do that. Yeah, here's the drive shaft speed. I need to upgrade change the record rate or the data rate there, but because that's what these dots are, is every data point. So I need to change that, but see where it flares here. Up here it goes to, it went from, where are we at here, 6,800 to 8,000 in race time 1.99, 1.79, 2/10 of a second. But yeah, other than that, you look down here, I think I still have, no, I don't have converter pressure in here. I'll put converter pressure back up here so you guys can see that. Yes, check this out. On the trans brake with the external dump open, not the internal, the external dump open, 86 pounds of trans pressure. So all the way up to 205, 208 there. And you can see the other thing that was happening right when I went off my tracks on the track is also the converter couple. As the pressure falls here, the converter's coupling. And it just started to couple. You can see that in the RPM trace too. It gets free, 7,000. Then it pulls it back a couple hundred RPM right before it spins the tire. And that is the issue with some of the harder coupling converters, like for example, this is a PTC 16.0, is that can happen. When the converter couples, it loads the tire hard, and it can spin the tire. So a couple things led to that. There's everything's adding up to both the track prep maybe not being 100% there yet, just because we went on it a little bit too soon after it was sprayed and it was so cold out, and then the converter coupling hard. Again, I don't want to pull power out of this thing because that is not our goal. Our goal here is to go better than the 859, and I know what kind of power it takes to do that. When we went that 859, we left on 20 pounds, just like we did here. We left on 19 pounds here, actually. And we ramped it to 24 on the same ramp. So we ramped this to 26 instead of 24, which didn't show fuel consumption-wise as a significant power difference. It only went up like 60 horsepower based on the injector duty difference, which was like 2%. Not anything huge. Anyway, yeah, so that's all the data we collected from that thing. I'm glad it shows that the turbo setup is promising looking, so I can just put this 94 on it rather than building a whole nother setup, which we talked about doing and would be fun because I enjoy that kind of work, but at the same time it's expensive and we won't have to do it. We'll throw a 94 on it and run it, and then we'll put that build engine in it and see what we can do in the half mile. Change the rear gear, obviously. It's going to be a good time. So that's it for this one. I'm going to start these next videos coming up are not going to be any data, any racing stuff. It's just going to be me working on the car. I'm going to put a list together, all the stuff we're going to change, and just work through that list. So keep following along, guys. Check it out.